Um, I honestly didn't look at Linux, so don't really give a fuck what an IO node is or some shit. iNodes. Anyway, um, so let's review what our purpose is. A lot of people think it should be more like Linux. I'm more impressed by the people who say it should be more like a Commodore 64 or more like DOS. Those people are smarter than the people that say it should be more like Linux. So if you're one of the people and you're begging me to change this or that to make it more like Linux, go fuck yourself. You're a retard. Okay? Fuck yourself. So, why? Because fucking use Linux. Well, you got a better idea? If you like Linux, use Linux. Okay, fuck yourself. So, I have reflected on how. Okay. First of all, this is not a This is a dual boot operating system. It's not your primary. God said 640 by 480 is a covenant like circumcision. So it's with 640 by 480 for all time. It's never going to be your choice for browsing, even if you could get a browser, because browsing with 640 by 480 just doesn't work. With 16 colors doesn't work. So once you accept that it's a supplemental, they got supplemental insurance. One time I used to talk about that, but I don't really believe in that. But anyway, so it's an add-on, okay? So let's define our purpose. First of all, a general purpose operating system has to do everything. It can't tell a customer, no, go fuck yourself, we can't do that. They have to do it, okay? At least that's what the professionals do today. They don't tell customers to go fuck themselves. They try hard to do everything. So, in this operating system, there already is a Linux as a fallback. So, we don't have to do everything. Now, why don't we do everything? Well, by cherry picking, we can create a differentiated product that if we don't do the crappy shit, then we can make a cherry picked, really elegant, beautiful thing. And you're just kind of out of luck if you want to do something it won't do. So what I focused on was the Commodore 64. I don't know. So what did you do with the Commodore 64? Well, mostly you played games. It was not networked and you played games. So I've developed probably 30 games and lots of demonstrations. I don't know. Are there 30? There might. Okay, so I have I have an application directory. We have about 10 games here, and then there's the demo games directory. Demo games directory. And we have some games here. So, you know, in order to explain, shut up, bird. In order to explain myself, this is not a perfect definition. Roughly speaking, we want to do these games as elegantly as possible, and that's what the operating system is built for. So all other games fall somewhere within okay, that's not entirely true. We have some kind of weird powerful office, what would you call it? I don't know. So date time. If you're doing games, do you need dates and times? No, not at all. Well, we do dates and times. Do you need forms for entering data, like data forms and stuff? No, for video games, you don't need forms. There might be a game here or there. Okay, so just a rough approximation. We want to do these games, and we want to do it with we're not trying for maximum efficiency, we're trying for minimum complexity. So generally speaking, what the industry does, if there's a way to make it 2% more efficient and it kind of clusterfucks the code, the people go ahead and clusterfuck the code to make it 2% more efficient. Okay, I don't unroll loops. I just don't like that. What? Make your own operating system. In my compiler. So stuff like that. I do all my my binary. Well, we might as well be looking at a function. What do you want to look at? Let's see. How about one of the math functions? Unassemble function. So it turns out somebody already used this name. I was very proud of this name. So this is a triangle wave. If you you know how you have sine waves and cosine waves. This is a triangle wave. I was very proud of it. It's weird. It has a period. So I wrote these back when I have an HD audio driver I used to have, and I was generating waveforms like a Commodore, and so I was doing it with these. Anyway, so no, I wasn't doing it with those. I was doing it more efficiently. So this is, we just want to look at the parameters are passed on the stack. They're not in registers. The arguments are popped by the callee with, I didn't even know about this instruction at first. So you can pop 16 bytes off the stack when you exit. That's to remove 2 arguments. So that's for 2 arguments. Is that in fact, so we have 2 arguments, yeah. So this is my compiler's output. Incidentally, you will find some fixed point integer, like for my circle. The little kiddies say, oh, he didn't have a floating point processor. No, integer math is faster than float. Well, as long as you don't have to go too far out of your way. So fixed point integer. So here's a problem for you. Let's say you want to store the number $5.34. By the way, you have to do double dollar signs if you want a literal dollar sign. Okay. Let's say you want to store $5.34 as an integer. Well, what if we multiply by 100 and we say I64I equals 534? Now we have an integer value that operates faster and well, I don't think it's any. So is there any confusion? So let's pretend you wanted a well, in this case we took 100 times the value into I equals 100 times the value. I'm a ninja with all the keyboard tricks. Some of them I'm hitting are pretty. I don't even know what I'm hitting. What am I hitting? Control Shift Enter is carriage return without triggering a carriage return. Okay, so you can also take 1,000 times the value. Now you have 12 bits of float. So this is fixed point math, okay? So just be aware. Oh, by the way, this is graphics mode, not text mode. I'm gonna show you. There's a famous story about a man who spent a week working to get a graphics package started, and he showed his boss his screen after a week, and he said, "I'm so excited, I have this black rectangle." And his boss kind of looks at him. "You worked a week and you have a black rectangle? That's what you're excited about?" Or triangle, whatever, rectangle, triangle. So now that's true of X Windows and Motif. That's last time I did graphics on Linux, that's what it was. And I was not even motivated to figure out what the fuck's going on. So one line of code. now I sort of cheated. We're using the default device context, or would you call it default? What am I saying? We're using the default argument, which which uses the I think it's just GR. So let's look up GR circle, and it says device context GRDC. Okay, so at first I didn't have global variables clumped into structures. Apparently it's called GRDC. There's one that's DRGC2. Okay, so there's a persistent layer, which is superimposed onto the layer below. Okay, so every time the screen is drawn, the entire screen is filled with the text layer, and on top of that, okay, the text layer can have sprites. They will be, when will they be done? I'm getting confused. Okay. So there's a, you know how there's, some of you will understand what I'm talking about. There's B800 memory. There's B800 memory in VGA text mode. Well, we have something similar, but instead of 16 bits, it's 32 bits, and it's got more attributes. As a matter of fact, you can Control Shift P. I just did a, you can do superscripts and subscripts. What it does is that each character can be shifted off of its position by, what do you want, 8 pixels? Anyway, so as a matter of fact, there's a pan that will pan the entire layer. So there's 16 bits of shift. You need 8 bits for the pan, and you need 8 bits for the I think that's reasonable. If you shift more than 8 bits, you might get away with it, but then if you did a pan, it would, anyway, they get added together. So never mind. Okay, so there's a we're going to talk about the file system, weren't we? Okay, so so never mind. So there's a text layer that gets generated, and the graphics goes on top. That's updated 60 times a second, 30 times a second. And then finally there's a persistent layer, and then there's a mouse cursor. Okay, so it's a little bit explaining the text layer is a little bit out of sync. So what happens is, let's just go look at the code. Let's boot. I could clear that anyway. So in GR screen, when it comes time to update a window, what does it do? It updates the, okay, so there's documents. What are the document? What's this document stuff? So there's as you can see, there's a border with a few characters and stuff on it. As a matter of fact, that's a document. Windows has a client area and a mainframe area. Well, this has a border doc and a so if you look at CTask, so the task has a when you do put S or print, it goes to the put document. When it displays the document, and then it has the border document. Now normally these two are identical, the put and display. Oh crap. So for double buffering, you can write to the put, and you can call a routine to swap them. So the border doc. Okay, so I digress. So when you update a window, okay, so first of all, let's talk about some rules. So all applications run on Core 0. Okay, let's just put it this way. Everything is on Core 0 except when an application creates a slave on another core for doing calculations. It can update the screen. We're not using GPU, so that it's not shared memory. It's not. You would have a hard time accessing GPU with two multi-cores. Am I wrong? Anyway, well, they would have to be locked and coordinated and stuff. But anyway, so as a matter of fact, there's a memory buffer for the screen image, and the multi-cores can all access it. It's up to you to keep them out of each other's way. So anyway, so applications run on Core 0, and when they want slaves, they explicitly spawn them on the other cores. Each application can have there's only one window for each application, for each task. What the hell? God damn it, I hate when my mouth is disconnected from my brain. Okay. Each task can have one window. The way you handle child is you do a pop-up. Pop-up, no, yes. So now we just made a child, and so you don't have child windows. That creates a new task with a new window. That's a child. So each task has a symbol table. Each task has a heap, a data and a code heap. I can explain that, and the task on Core 0 can have a window, and the window order is the task order. Okay, so getting back to this. Hello? That's a thought. I don't think we're quite ready at this point. Maybe in a few months or maybe a year or something like that. But there's not really a lot of people at this point. So yeah, that's a good idea. I'll keep that in mind. What? I guess so. Yeah, I guess that would be a good place, huh? Convention centers and stuff. Okay, bye. He wanted to know if we'd ever have a convention. Yeah, maybe we could do that. So, update task docs. Okay, so let's dive down. What does this do? Well, what this does is it calls doc recalc. This is the work engine of the document framework. And sometimes you update the screen, sometimes you just recalculate the document. So this does the formatting and word wrap and all of that. So what happens at this point, it starts updating that B800 memory, and it also starts drawing, if there's sprites, it'll draw them. Now there's kind of a trick here, or there's the current B800 memory is updated next cycle, is put on the screen. The past B800 memory was anyway. There's a cycle lag between the text layer, or anyway. So it puts the B800 array onto the screen, and then it calls all these document updates, and those write to the new B800 array, but it also starts doing sprite graphics. Now that gets placed on the old text, so there's a it's never important. I don't even know why I confuse you. It's not important. So we draw the documents, and then we start doing these callbacks, and this is where the video games are done. The video games are drawn in, you make a draw it callback, okay, and finally there's controls. That's for like the border scroll bars, and you can make, it's actually, I thought it was going to be a big deal like in Windows, but it turns out you almost never do the controls. I have a couple games. Oh, you wouldn't be able to see it anyway. There's a picture of my face covering the corner. Anyway, so let's talk about, okay, so our purpose is to be, oops, damn it. So we want to, someone said, why don't you change it to 250,000 lines of code? And I was like, no, I don't like that idea. Someone else said change it to 50,000 lines of code. Then I was like, wow, that guy. Anyway, so if you told me get rid of all the office date time stuff and just do these minimally, that would be a pretty that would make a lot of sense. So pretty much the least in order to accomplish these games is so what do we got here? You might be curious to see what kind of games we have. So this is I have 24 cores, only 16 work in VMware. You'd be surprised, a lot of people say, it's not 3D. What are you talking about? It's just you multiply by I use a 4x4. So we have triangles. These scenes are made of triangles. I have a video on how to draw a triangle, if well, you use the library now, but if you didn't have the library, how do you draw a triangle? Well, you calculate the slope of the two sides, and then you step down one row at a time, and you draw a horizontal line. That's how you draw a triangle. For 3 dimensions, you have a slope in the, or a change in z, and when you're drawing the horizontal line, you update a depth buffer. What is a depth buffer? You make an array that's alongside that one, an array with a value for each pixel that holds the z coordinate of the of the nearest pixel. Anyway, and if it's even nearer, then you update it. If it's farther away, then you throw it away. So well, it is what it is. It's 3 dimensions. You know, you might find some people that say, get rid of the 3 dimensions. That's a step too far. That should be in the application. Well, you might get it down to 50,000 lines of code. But anyways, so what else do we have? We have a first-person shooter. It's done with so we have support for meshes and 3D objects. A mesh is a very strange label, since you never see the meshes. What it is it's objects made from triangles that are, it's a set of triangles with colors. What'd you call it? A set? Collection? I don't know what you want to call it. It's a mesh, I guess. So there's an editor, you can make them. The sprites actually are, they can either be 2 dimensions or with a mesh, and so you can create these in there and then plot them. And anyway, so it's kind of once you start talking about game engines, that is really awful. That sounds like hell to me. I like straight up programming, not being in somebody's, you know, I was going to explain something. I know what. So this is enlightening. So in Linux, so I made my own compiler, and there are no defined functions. You can say define something, you know, this, and then say, well, anyway, but there are no defined functions, and those are niggerlicious. You get these little in there, and they start making all kinds of crazy squirrely stuff. Nobody has any idea what's going on, and they get their jollies out of making these little contraptions and shit. Somebody comes in there that wants C++, and in Linux they only have C, and so now you got this crazy, it's really delicious. So we don't have any defined functions. So that should be a shock, because most people assume that my language is delicious defined functions. No, it's straight up compiler with no defined functions. So let's talk about this. I'm not real thrilled when somebody gets their jollies making some delicious invention in his own imagination. So that's what it feels like when if I'm working in a game engine. It's like, oh great, you know, somebody created this out of their imagination, and now this is my environment. I got these. So I don't really like that. I like to be at a building block stage. I don't like being stuck in the realm of somebody else's creations. That's not the legitimate. If you didn't make a language, I really don't want to be. Anyway, so I used to joke that Bill Gates might say something like, in the bad old days, we had to program in 6502 assembly language and make binary graphics by hand. You kids are so lucky, you get to do 100 fonts in HTML. And then somebody says, which would you prefer? HTML or 6502 assembly? And he goes, oh, well, I'm a lot smarter than you. So it's like, ah, fuck you. So if you ask the Linux people, well, anyway, they want to pursue the when the Commodore 64 existed, there were 20 million of them, and they didn't make it for. It was pretty much they just don't enjoy programming and stuff, and Bill Gates and other people said, we're gonna make it so that everybody can use it, and that's not how the Commodore 64 was, and we're not doing that, okay? We're keeping it true. Something like. Anyway, so I think I've had. Oh, I was going to talk about. We're going to talk about inodes. So let's talk about the philosophy of disk access. So we want to play one video game at a time. When we play a video game, maybe we want a song in the background. And if you're doing a song in the background, that's nice with a task that just sits there and plays a song. Piece of cake. And if you're doing animation, let's say you want the animation happening in the background, so you make an animation task that loops and does the animation. And there's even beginners will benefit from multitasking. The Commodore and DOS were not multitasking. This is multitasking. However, perhaps we should call, for those of you who know the difference in process, thread, and task, this is a single address map, which means paging's not really not used for the most part. So everybody's on the same map physical and virtual addresses are identical. So if there's not a difference in thread and process. We don't even use those words. We just use the word task. So you won't find the word process, you won't find the word thread used anywhere. All we have are tasks. And so if this were threaded and processed, then since we're running one video game with multiple threads, you might call this single process multiple thread. Now that's kind of a profound, we're not saying, well, it will run it, but we don't really, even though you won't have any problem, we only want to run one video game at a time. You can run 2 video games at a time, but we only want to, that's silly. Let's pretend we only want to run one video game at a time. I could make it hard-coded, but we don't have any of that. So, in other words, if this is not a server, so like if there's disk activity, if it's a video game and it's doing disk activity, we're not breaking it and sharing it. When you have a multi-processing operating system, like a normal one, then if one process does a really huge disk request, you don't want to starve the other one. You want to give him a little bit of time. So what they do in normal operating systems is they break requests into pieces so that it's not locked to one, so one's not hogging it. So there's not really sharing. So there's locks. I have locks. If you try and access it with 2 different tasks, it's going to, there's locks. Now, okay, so we don't have, what did they call those? No, we don't have, when I say there's locks, it's not, as a matter of fact, there are no file locks. There's a lock on the disk and a lock on the partition, but there's not a lock on files. So it's not how does it handle updating a let's say you do a write operation and you want it atomic? Well, if you write to the disk, it's going to that task has control, and it never releases it until it's finished updating the directory. Well, that could be wrong. I think I'm wrong. Am I right? No, I think it locks the partition. It locks the partition. Anyway, why am I talking about this? Honestly, I don't press my luck, which is kind of shameful, but I don't run things in the background. I just do stuff in the foreground, and I'm scared that something's going to go wrong. It hasn't really been hammered with testing. Now, is that important? Well, theoretically, it's not even important. We could make it important. It would be nice to run stuff in the background, I guess. But, so what does all this minimal stuff get us? Now, when you press F1, you get a list, and this is all the functions in the operating system. This is the categories. So we can look at, there's a hash symbol table, and these are the hash functions. We can look at this is kind of intimidating. We can look at the graphics. These are all the graphics functions: plot, circle, B-spline. array multi sprites PMP. So when I was on Linux, there was a time when I was overwhelmed and I couldn't see the light at the end of the tunnel. And the most important thing I want is for everybody to see the light at the end of the tunnel. I want them to come in here, click one of these, say, okay, each one, in their mind, they're going to think each one of these is a couple pages, and each one of these is a couple pages, and the whole thing is a page, a little more. So that's not too bad. You know, a couple weeks, I could actually investigate everything about the whole operating system. So that's the goal. What I want is it's supposed to be small enough so you can see the light at the end of the tunnel. I don't want you in the middle of the ocean just floundering with no idea how deep it is. So that's the goal. That's what the 100,000 lines achieves.